It feels like we spent the last few years building this massive gleaming fleet of supersonic jets.
Right.
Like everyone is standing around on the tarmac just marveling at the engines, the speed, the revolutionary software.
Right.
But we're just now waking up and realizing nobody actually poured the concrete for the runways.
Yeah, no runaways at all. It's a phenomenal reality check, honestly.
We are in the middle of a massive shift right now. It's what the macroeconomic data is calling the great decoupling of the AI industry. Basically, the software hype cycle has officially crashed headfirst into the brick wall of physics and human operations.
It really has. We're trying to fly at Mach 3 into the future, but we are completely grounded by physical dirt, industrial supply chains, and just the messy human realities that we essentially tried to ignore for the last 3 years.
Right, so today, our mission is to deliver a definitive 2026 State of AI briefing. We are cutting through all that endless market noise, the shiny software demos, and the trillion-dollar press release to explain exactly what this great decoupling looks like on the ground.
And we have a lot of ground to cover.
We do. We're pulling from a massive stack of industry analytics, enterprise IT audits, including MIT's 2025 State of AI report, plus supply chain telemetry and infrastructure data. And whether you are an enterprise leader trying to figure out your next move, an investor, or just someone who is insanely curious about where tech is actually heading, you're probably feeling the whiplash.
Oh, totally. The whiplash is real.
Right. You see these massive AI spending announcements on one hand, and then a bizarre, confusing lack of real-world results on the other.
Yeah, and to understand why those results are missing, we basically have to stop looking at the software entirely.
Really?
Entirely.
I mean, mostly, yeah. We have to start looking at the thermodynamics. Because the AI build-out is no longer a coding challenge, we sort of solve the algorithmic scaling piece. What we are facing now is a heavy industrial bottleneck.
Okay, let's put some numbers to that scale first, because the capital expenditure is, frankly, it's almost hard to comprehend.
I agree. Yeah. The top hyperscalers, the massive tech giants running the cloud, they're spending between $660 billion and $775 billion on infrastructure in 2026 alone.
Just this year.
Just this year. There are individual projects like that Stargate supercomputer initiative targeting $500 billion just by themselves. That is $500 billion for one compute cluster.
It is astronomical, but this is exactly where the conversation has to shift from dollars to watts. When you look at the physical reality of what they're actually buying, it's mind-blowing.
How so?
Well, a standard corporate data center rack like the physical metal cabinet holding the servers, that used to draw maybe 10 or 15 kilowatts of power.
Okay, 10 to 15.
Right. The next generation racks we're seeing deployed right now, like the ones housing NVIDIA's B200 chips, are drawing anywhere from 100 kilowatts to 250 kilowatts per single rack.
Wow. Just to visualize that for you, the listener, that means a standard 10-megawatt data hall, which is essentially just a large warehouse room, is now drawing the exact same amount of raw electricity as a small city block. But that heat and power draw is packed into a single enclosed room.
And that thermal density, it just fundamentally breaks our existing infrastructure. I mean, the electrical grid simply cannot handle a localized power draw of that magnitude suddenly popping up in some suburban industrial park.
Right.
If you want to build one of these facilities today, the interconnection queues in the U.S., which is literally just the waiting list to get the local utility to plug your data center into the grid, those are stretching 7 to 10 years.
Wait, 10 years? So you could spend $1 billion building a state-of-the-art facility, and it just sits there in the dark until 2036.
Exactly, it just sits there. Because the utility companies, they have to build new substations, route new high-voltage transmission lines, and manufacture these massive transformers. And just procuring those transformers takes years.
That's insane.
It is. Because of this physical bottleneck, between 30% and 50% of all the massive AI data centers planned for 2026 are already being delayed into 2027 or 2028. The grid just literally said no.
So if you're a tech giant and you are in this brutal arms race where a 10-year delay is essentially a death sentence, what do?
You bypass it.
Right. Looking at the infrastructure data, they are pivoting aggressively to what the industry calls behind-the-meter power, meaning they are bypassing the public grid entirely.
Yeah, they have to.
We are talking about over 101 gigawatts of on-site gas and nuclear generation being announced to power these facilities directly. And looking at this strictly from a factual infrastructural lens setting all politics completely aside, Projects like Stargate are seeing the Trump administration step in to fast-track these private gas plants. It is a pure bypass mechanism for gridlock, regardless of how you feel about energy policy. They are treating compute like a critical national resource.
I would actually take that a step further. Tech companies are basically being forced to become heavy industrial utility providers just to keep their algorithms running.
Right.
But here's the thing. Electricity is only half the physical battle here. The supply chain for the raw materials is just as broken. The components required to build these AI servers are critically short.
Like what?
Take high bandwidth memory, or HBM. It is a highly specialized, stacked type of memory chip that these AI processors desperately need just to feed data into the model fast enough.
And the telemetry data shows HBM is entirely sold out globally through the end of 2026.
Completely gone. You can't get it. And because HBM is so difficult and resource intensive to manufacture, it is currently consuming 23% of all global DRAM wafers.
Wow, almost a quarter.
Yeah. So the factories are prioritizing this highly profitable AI memory, which creates this massive ripple effect down the entire tech supply chain.
Which explains the situation with PMICs. This really stood out to me in the data. We're not just short on the cutting-edge, space-age chips. We're short on PMIC's power management integrated circuits.
Oh, the PMIC shortage is wild.
These are like boring, mature node, basic power regulators that cost a few dollars.
Yeah.
But right now, the lead time on ordering them is 35 to 40 weeks. Because the fabrication plants are dedicating all their capacity to a $30,000 AI chip, nobody is making the $2 power regulator that the server actually needs to turn on.
It's the classic weak link in the supply chain. And this scarcity across the board is driving infrastructure costs through the roof. If you want to build an AI-optimized data center right now, it costs between $30 million and $40 million per megawatt.
That is just wow.
Just the sheer volume of wiring, the massive bus bars and the liquid cooling pipes required,
Wow.
It's driven the cost of raw industrial materials like copper up to $5.61 a pound.
Okay, let's unpack this for a second, because we've always been taught that the cloud is just someone else's computer, right?
That's the old saying.
It's marketed as this ethereal, weightless, infinite thing. But looking at these material constraints, the 2026 AI cloud is basically just someone else's nuclear power plant and a dedicated copper mine.
Spot on. That is the exact paradigm shift that enterprise leaders need to internalize today. And it is exactly why so many IT infrastructure directors are failing right now.
How so?
Well, if you are a leader who budgets for FLOPs, meaning computing power first and watts second, you have already lost the race. The primary barrier to advancing your company's AI capability is no longer software engineering. It is metallurgy, industrial logistics, and securing a massive, uninterrupted flow of raw electricity.
Because these data centers are now costing $40 million per megawatt, compute is practically as expensive as enriched uranium,
Pretty much.
which means companies are absolutely desperate to squeeze a massive return on investment out of it. But when you look at the enterprise data, they aren't.
Yeah.
They just aren't.
Let's pivot to the second piece of this decoupling, the enterprise paradox.
This is where it gets really messy.
Right. Global AI spending hit $2.59 trillion this year, yet organizations are overwhelmingly failing to capture any real value from it. Yeah, the MIT 2025 State of AI report has a truly sobering statistic that illustrates this perfectly. They found that 95% of generative AI pilots fail to reach production or deliver any measurable ROI.
95%. I mean, how is it structurally possible to burn through $2.5 trillion and have 95% of your projects just die in the sandbox?
It comes down to a massive systemic misallocation of resources. The data shows that over 50% of corporate AI budgets are being poured into flashy front office sales and marketing projects.
Oh, the chatbots.
Exactly. Executives want the highly visible chat agent that talks to customers. Those projects look incredible in board presentations. But structurally, they take 2 to 4 years to show any actual financial payback.
2 to 4 years.
Yep. Meanwhile, the highest ROI is consistently found in boring, invisible back-office automation. Things like complex document processing, supply chain reconciliation, internal HR workflow.
The unsexy stuff.
Exactly. Those projects pay back their investment in just 6 to 18 months, but they only get a fraction of the funding because they aren't glamorous to show off.
But the failures go so much deeper than just picking the wrong projects to fund. There is a real human cost here that is actively backfiring on companies.
The boomerang.
Yes, the AI boomerang. The labor data outlines this brutal trend. In the first half of 2026 alone, Over 100,000 corporate layoffs were explicitly attributed to companies replacing human workers with AI agents. But here's the boomerang effect. 52.1% of those exact same companies are actively rehiring for the exact same roles within 6 months.
It's wild. Klarna is the global poster child for this right now. They aggressively moved to replace a massive portion of their human customer service team with an AI agent. It made huge headlines.
I remember that.
But within months, they had to reverse course and rapidly rehire 700 workers. And this fire and rehire cycle is incredibly destructive to a balance sheet. The analytics show it costs companies $1.27 for every dollar they initially thought they saved.
Ouch. So what is the mechanism breaking down here? Like, why is the AI failing to actually do the jobs these companies bought it for?
It comes down to a concept called tribal knowledge.
Tribal knowledge.
Right. Tribal knowledge is the vast web of unwritten rules inside an organization. It's the exception handling. It's the historical context. It's the implicit human understanding of why a certain process works the way it does.
And the AI doesn't have that.
Exactly. AI models optimize for plausible average outputs based on their training data, but they have no inherent business context. So they handle the perfectly standard middle-of-the-road tasks fine, but without that human tribal knowledge, they fail catastrophically on the edge cases.
Let me see if I can map this out with an analogy. It's like a logistics company relying on a new AI GPS system, right? The AI perfectly knows the official speed limits and the mathematically shortest route. But it doesn't know that one specific bridge floods every time it rains, or that the loading dock at a certain warehouse is always blocked by delivery trucks before 9 a.m. The locals, your human employees, they know to take the detour. They have the tribal knowledge. But the AI just confidently drives the truck right into the river.
Perfectly put.
So are companies essentially paying a massive stupidity tax for deleting their own institutional memory?
Yes. But it's actually even more systemic than that. You don't just lose the detour knowledge, you lose the ability to improve the system entirely.
What do you mean?
Well, AI effectively raises the floor of your operations. It handles the routine, high-volume, repetitive middle incredibly well. But humans still set the ceiling. Humans are the ones who handle the chaotic exceptions, the nuanced judgment calls, and the angry clients.
Right.
When an executive amputates that human layer to save a quick buck, they completely remove the ceiling of their organization's capability.
And the data shows the companies actually winning with AI are the ones who understand that exact distinction.
Exactly. Contrast those boomerang companies with a legacy giant like IBM. IBM successfully automated 94% of their routine, repetitive HR tasks. But they didn't fire the HR staff.
Right, they kept them.
They redeployed them. They moved them to higher value, judgment-based work like employee retention strategy and complex dispute resolution. They avoided the boomerang effect entirely because they used the compute to augment their people's capabilities rather than amputating the workforce.
This is so smart. And this brings us to the third and honestly most alarming dynamic happening right now.
The verification gap.
Exactly. If compute is insanely expensive and enterprises are desperately rehiring humans to supervise the AI because they lost their tribal knowledge, what happens when the AI is producing output vastly faster than those rehired humans can possibly read it?
Yeah, this is the crisis defining the software engineering world today.
The verification gap. This is where the sheer velocity of AI shifts from an asset into a massive liability. Right now, AI assistants account for 42% of all newly committed software code globally.
Almost half.
Almost half. And these coding agents can generate complex logic up to 8 times faster than a human developer.
But the telemetry from software repositories shows that this velocity is essentially a mirage, right?
It is a complete illusion. Yes, the AI is generating an entire feature module 8 times faster. But for anyone not living in GitHub all day, before that code can go live, a human has to review it in what's called a pull request or a PR.
Right.
And the time it takes humans to review those PRs has skyrocketed by 91%. So the actual delivery velocity, the time it takes to get working software to the customer, remains completely flat.
Because the bottleneck didn't disappear?
Exactly. It just shifted from the act of writing code to the grueling act of reading it.
And reading code you didn't write is notoriously harder than writing it yourself.
Oh, 100%.
Especially when the quality of what is being generated is actively degrading. The data shows AI-authored pull requests average 10.83 issues compared to 6.45 for human-written code.
Wow.
That is a 1.7x higher defect rate. And this metric blew my mind. code churn, which is the percentage of code that gets pushed to production but has to be completely rewritten or deleted within 2 weeks. That has jumped from 3.1% to 5.7%.
That's a massive jump in wasted work.
It is. And this degradation is why developer trust in AI tools has collapsed down to 29%. 96% of developers openly admit they do not fully trust AI output.
96%.
Yeah. And yet, this is the terrifying part of the data. 62% of tech leaders admit their teams are actively shipping AI-generated code to production without manual, line-by-line verification.
Wait. If they don't trust it, why are they shipping it? Is it just fatigue? Like, if I'm supposed to proofread an 800-page technical manual written by an AI, and I only have 10 seconds to do it before my boss demands the next feature, I'm just going to skim the first page and stamp it approved.
Exactly.
Are developers basically just skimming code now, and as a result, accumulating this massive invisible credit card debt of broken logic?
Yes, and the industry has a specific name for it now: cognitive debt, or sometimes verification debt. Developers are being forced to maintain massive code bases, built entirely of logic they did not create, do not fully understand, and simply skimmed over during the review process.
And what does that actually lead to?
It leads to what researchers call the rise of silent gray errors.
Let me stop you there.
Yeah.
I know what a syntax error is. You miss a semicolon, the code breaks, the compiler yells at you, and the app crashes. It's obvious. What makes an error gray?
A gray error is insidious because it looks syntactically flawless. It compiles perfectly, the application runs smoothly, but it executes the completely incorrect business logic.
Give me an example of how that happens in the real world.
Okay, say your company has a legacy rule where enterprise clients get a 10% discount on orders placed on Tuesdays.
Okay, simple enough.
It's tribal knowledge, hard-coded into some old module. The AI agent gets tasked with rewriting the billing system. It writes beautiful, hyper-efficient code, but it doesn't know about the Tuesday rule. So it silently overwrites it. The code reviews perfectly on a syntax level. It gets shipped. And for the next 6 months, the system quietly overcharges your most important clients, and nobody realizes it until a massive lawsuit hits. It confidently does the wrong thing.
That is terrifying.
Truly.
So, if human developers physically cannot keep up with reading and verifying the fire hose of AI code, the obvious tech industry instinct would be, well, let's just deploy another AI to review the first AI's code, right?
I would strongly caution against that.
Why?
If we connect this back to how these models actually function under the hood, using AI to grade its own homework is incredibly dangerous. It just creates a validation loop for the model's own hallucinations.
Because they share the same blind spot?
Exactly. If the primary AI misunderstood the Tuesday discount logic when it wrote the billing code, the reviewer AI, which is built on the exact same statistical foundations and lacks the exact same tribal knowledge, is going to make the exact same logical error when it checks it. It will give a perfect score to a broken system.
So if humans are too slow and AI self-review is too dangerous, what does a successful software development team actually look like in 2026? How do you leverage this tool without drowning your company in cognitive debt?
The engineering teams actually succeeding right now have shifted to a workflow they call Vibe, then Verify.
Vibe, then verify. I like that.
You use the AI for the initial creative generation, the vibe, the rough draft, the heavy lifting. But you absolutely do not rely on blind human trust or AI self-review for the verification phase. You have to provide these AI agents with strict, deterministic, structural guardrails.
What does that look like practically? Because the engineering data points to tools like RAMPS Inspect Agent as the new standard here.
Yes, RAMPS Inspect Agent is a great mechanism to look at. In a legacy setup, a human writes code, and then the human runs a test suite to see if it works. What teams are doing now is giving the AI agent actual structural access to the CI/CD pipeline, the continuous integration and continuous deployment system.
Basically, the automated factory floor where your software is built and tested.
Exactly. You give the agent the ability to run the automated test suite itself. So instead of just guessing if its code looks right, the agent writes the code, compiles it, runs the enterprise test suite, sees that the Tuesday discount failed, and rewrites its own code until the deterministic test passes.
I see.
Verification has to be structural and grounded in reality, not just a quick human skim of a pull request.
So what does this all mean for you, the listener? Whether you are evaluating an AI integration project at your company, allocating investment capital in the tech sector, or just trying to navigate where this economy is going, you have to look past the pristine software demos.
The demos are easy. You can generate a demo on a laptop. The reality of enterprise deployment is incredibly hard.
Exactly. Success in 2026 relies on three very grounded physical realities. One, you have to secure the physical power, the cooling, and the supply chain components to actually run the compute. Two, you have to aggressively maintain and protect the human tribal knowledge that actually makes your specific business run, augmenting your workforce instead of amputating it.
Spot on.
And three, you have to rigorously and structurally verify AI outputs through automated pipelines so you don't drown your organization in cognitive debt and silent gray errors.
You know, this raises a fascinating and frankly daunting question as we look just a bit further down the road.
Okay.
If AI scaling is currently hitting a brutal physical wall of power grid limitations and simultaneously hitting a human wall of verification constraints, what happens in the near future when these autonomous AI agents are tasked with directly negotiating for or even fighting over raw power grid resources to solve their own computation bottlenecks?
Oh, wow.
Right. Could the next era of AI competition be fought not in repositories of code, but over the physical control and routing of raw electricity?
That is a wild, very tangible thought to leave you with. It brings us right back to those supersonic jets sitting on an empty dirt lot. We built the software of the future, but now we are scrambling to pour the concrete, secure the copper, and hire back the air traffic controllers before the whole thing runs out of fuel. Thank you for joining us on this deep dive. Keep questioning the hype, keep looking at the physical reality behind the screen, and we will catch you next time.